I would like to welcome to the stage Taifun and Yiling from Accenture and Prasad from MongoDB, and they are going to talk about a hybrid LLM model. So without further ado, I will hand over to Taifun, who will kick things off.
Hello, everyone. Can you hear me? Okay? All good? Okay, you guys are good? Cool. Well, good afternoon. My name is Taifun. I'm here with Yiling from Accenture, and we also have Prasad, and we're going to talk to you about what Jumpstart is, what we've achieved in the past year or so. I'm pretty sure you heard a lot about RAG today and vector databases. So we're going to build on top of that, hopefully, and it'll be very exciting. So what we're going to do, we're going to talk about how we achieved knowledge graphs with MongoDB and how we've been able to implement a HybridRAG. Before going to the details, let me talk to you a little bit about what Jumpstart is. So Jumpstart is a GenAI Accelerator that is meant to be multi-cloud and LLM agnostic. So we want you to be able to deploy it to any cloud environment and choose your LLM or generative model. To achieve this, what we've done, we basically containerize all of our expertise from Accenture, from MongoDB, and to provide you guys a containerized application, an accelerator that you can deploy, run as a microservice, and utilize its APIs so that you can build your GenAI application on top. So you don't have to worry about the complexities of GenAI and what to do with it. We take care of it, and you can focus on the value of your application. I know this slide is a bit of an eyesore, so I'm not going to go to the details of everything. But just to kind of highlight a couple of values that we give to you with Jumpstart. One is rapid deployment. In day one, you can deploy Jumpstart to your cloud environment and then configure it to work with any LLM that you want. The MongoDB comes out of the box, and we can configure it all, and then you can start using Jumpstart's API and build your application on top of that. Another cool feature is MongoDB being cross-platform. You can choose your cloud environment, so you can have one Jumpstart deployed in Atlas, in Azure, another one in AWS, and that's all fine. So we have that cloud-agnostic view as well. Another cool feature is scalability. Because everything is containerized, you can run your microservice as you want, and you can scale it up and down depending on the traffic. And obviously, last but not least, is the DevX, which is really important because we provide you all the APIs that you need for your RAG applications, for your HybridRAG applications, and you can choose your chunking method. You can choose anything and everything that you would need for your GenAI application, and then start rolling right after that. With that said, I'm going to pass on to Yiling, who's going to talk about cool features about architecture.
Thank you, Taifun. So in our Jumpstart Accelerator, we implemented HybridRAG. Before then, we were adopting VectorRAG, traditional VectorRAG, which only captures semantic relations. So we decided to add a mix to the ingredient. In our latest feature, we enable knowledge graph. But before going into the details, I want to sort of briefly outline two techniques. One you've already heard a lot today, traditional VectorRAG. So with traditional VectorRAG, the documents are first chunked and then embedded. Embeddings are basically a way of converting words or sentences into numbers that capture meanings and relationships. Once these are embedded, the embeddings are stored in a vector database. So when a user asks a question, the question is embedded using the same embedding model, and then it uses some similarity search to pull out the most relevant chunk from the vector database before passing that to the model to get a response. Well, that works great at finding contextually relevant knowledges because your LLM is confined to its training data, and amongst other advantages like mitigating a hallucination. But it can only identify similarity between data points based on sheer numerical proximity, because when the data is vectorized, these contextually relevant the context that informs the relationship between different data points are obscured. And this brings us to knowledge graph. Knowledge graph are basically a network of interconnected nodes and edges. It's made up of nodes, edges, and sometimes properties. Nodes represent entities such as people, place, locations. Edges, on the other hand, represent the relationships between these nodes. It's the connections between the nodes that define how they interact with one another. And properties, sometimes you have properties. Properties are just extra information about your nodes and edges. It makes your data more informative. So if you take a look at this knowledge graph, if you can see the words, you can see a node called stress, and there's a node called physical activity below it. And between these two nodes, there's an edge called reduces. So the relationship here is stress reduces physical activity. And you follow the edge again, you can see that physical activity also improves cognitive function. So being able to traverse the graph like this, it allows you to understand how nodes are connected. And in MongoDB, this is achieved through the graph lookup aggregation pipeline, which Prasad will go over it in a bit more detail later. These characteristics allows knowledge graph to map connections between different data points in different data source, even when they're referencing the same entity. But while there are great advantages with using knowledge graph in your RAG, it's worth bearing in mind that it requires specialized skills and also computational power to build and maintain such graph. And this brings me to HybridRAG, which combines the strength of both VectorRAG and knowledge graph to retrieve contextually richer information. The same process applies here. The documents are ingested. And then in the VectorRAG part, these are chunked, embedded. In our case, this was stored in a MongoDB collection. Worth noting here is that both the embedding and the chunk document are stored in the same collection. In the knowledge graph part, we use a LangChain graph transformer to create the nodes and edges. Again, these are stored in the MongoDB collection. The output from both of these techniques are then passed to the model to give contextually relevant and intricate relationships. And this slide basically is better visual representation of the previous slide. So as you can see, the documents are chunked, embedded, stored in a MongoDB collection. Similarly, the nodes and edges are extracted from the graph transformer. It's a little bird here. And then they are stored in a MongoDB collection. There's an intermediate step here, which is the chunks from each chunk in the embedded chunk collection is vector search against the nodes relationship collection to find a matching node from that chunk. And that node is also stored in the same collection as the chunk. And then the same process applies again. The user asks a question. The relevant chunk is retrieved from the embedded chunk collection. At the same time, the node from that chunk is passed into the graph lookup aggregation pipeline to find the graph relationships. And both graph relationship and the relevant chunk are passed back to the model to give a response. And this works great so far, except that we find that the nodes that are extracted from the chunk was a bit biased. So in an example, using stress journal articles, and a lot of nodes that were appearing along with the chunk were stressed due to the context of the chunk. So we did a little modification in our second version. In this version, pretty much everything is the same, except that the nodes are now not coming from the chunk. They're coming from the question itself. So the entities are being instructed from the question, and then the nodes from the question are passed into the graph lookup aggregation pipeline to extract the relationship. And then the relationships, along with the relevant chunk, are passed to the model and to give a response to the user. And we find that that worked much better at capturing the right notes for the question being asked. And now I'll hand it over to Prasad to go over the steps a bit more details.
Thank you. Thank you, Typhoon and Yiling, for taking us through the problem statement and the architecture. So when Accenture approached us to discuss around this problem statement, we found that the document data model from MongoDB is the right way to store this information that is gathered. Document data model helps you to store both the operational data of that use case along with the vector embeddings that get generated. So it provides that single operational query to the developers to, to, to ask questions both on the vector embeddings and on the operational data set. So, and that's why MongoDB is part of the Jumpstart. Through Jumpstart, we are able to help develop these applications on any compute, on any infrastructure, and provide that AI experience to the end users. So relating back to the problem statement that Yiling just mentioned around a particular query that is coming from a user, right? How is social support related to aging? We took that particular query and a set of healthcare documents to really ask that question and find out what would be the LLM response and to check the accuracy of LLMs. So we created that embeddings with a certain set of PDF documents. Right, the first results that we got on LLMs with the basic VectorRAG had hallucinations. Right, we then created a knowledge graph from those PDF chunks, stored the objects and the relationships within MongoDB Atlas that helps us to understand. You can see now that the objects like mental health is related to the quality of sleep, right? And whether it reduces, increases, the impact is also captured in the same hierarchy within MongoDB Atlas. So we took that depth-first hybrid search approach and asked that a graph lookup on MongoDB. So when you pass the derived graph, right, the derived graph that got from the user query, how is social support related to aging, we got derived graph that constituted the mental health and the sleep quality. All of this derived graph information was passed to MongoDB, right, was passed to the LLM. So essentially, to put these things into perspective, right, MongoDB Atlas is now helping the components to be developed within Accenture Jumpstart that are based on the vector search, the full text search, and also to do a graph lookup that increases the accuracy of response from LLMs. Okay, with that context, I'll pass that back to Typhoon.
Okay, thank you, Prasad. Right, let's give everything we've talked about some context now, shall we? So I'm going to talk a little bit about BrainGym. I don't know how much time I've got, but I'm assuming I'm going to have a few minutes. So I'm going to introduce what BrainGym is and how Jumpstart is applied. And then I'm going to give you guys two comparisons between a traditional RAG and a hybrid RAG and how the response quality between the two changes. So this probably is going to help you a little bit contextualize the differences we're talking about with relationships. In a very nutshell, what BrainGym is, what a gym is to an athlete or anyone who wants to get a bit of exercise, BrainGym is for us. It's a way to build and train your brain muscle. So it's for the talent. It is a platform we're developing here in Accenture using wearables, bio-wearables, so things that can listen to your brain, things that listen to your heart, and make sure that we provide a platform where you can train for your brain. It is a very brief description, but I think the gym analogy is good enough for you to kind of think about what it could be. If you have time, we will be at the booth. You can come and see us, and I can give you more details. So I'm not going to talk about the wearable side of this at all today, but going to focus on what we call the coach. So if you go to a gym, you got your coach. You can ask questions about your, maybe well-being or maybe your exercise regime, your food. We wanted to bring the same experience to BrainGym. And what we did, we deployed Jumpstart, as you can think about, and we utilized its APIs to bring the coach to life. So the coach has a knowledge base, and you can ask questions to the coach, and you can get responses back. In the next two examples I'm going to show you, there is a comparison. So the first comparison will be the coach utilizing Jumpstart with a traditional RAG, and the second example will be the BrainGym coach utilizing Jumpstart with a HybridRAG, and then you guys can tell me the difference. Okay, let's do it. So the first one is about a question that is actually asking what is the relationship between stress and sleep quality. If you look at the response, you see that even though the knowledge base might contain information about the two entities, sleep quality and stress, it doesn't really give you an answer. It says the provided context does not contain any information about the relationship between the two. So this is a response that you might get from traditional or VectorRAG. The next example is when we combine the two, so we add and build on top of the existing RAG system with a HybridRAG with knowledge graphs, and the response from the same knowledge base changes dramatically. It suddenly starts talking about, oh, the sleep quality and stress might be related in X, Y, Z. And the reason this happens is because we have the graph base, we have the knowledge graphs, where stress might be linked to many different entities. And because our questions about sleep quality, the graph lookup traverses the whole knowledge base and gives you a response back. So the whole experience of RAG changes a lot. In the first example, there was no response. It just said we don't know anything about this. But from the same knowledge base, in the second method, we will actually retrieve some good quality response. The second example is very similar. So this time, it is asking about how does stress impact my mental health. I'm not going to read through the whole response, but you basically get a paragraph about how stress could be related to your mental health, and it doesn't give you much details about what could be the relationships of stress to different things that might be in your life. This is VectorRAG, and if I look at the second example where we run the same knowledge base, but instead of a traditional RAG, we use HybridRAG, and the response suddenly changes. Now we have a list of different things that might be relational to your stress in your life, and then you kind of get a better, more detailed answer response that is based on the relationships between stress and your mental well-being overall. I hope these two examples give a little bit of an introduction to how traditional RAG and RAG that is based on or extended with knowledge graphs might provide an enriched response. That said, I'm going to give back to Yi-Ling to wrap up, really.
Thank you, Tae-Phong. Is this on? So in our latest feature, we find that VectorRAG with knowledge graph complement each other. But this really depends on your use case. So if your use case is a simple semantic search, then VectorRAG will be sufficient. But as soon as complex relationships are involved, then VectorRAG starts struggling, and that's where knowledge graph will shine. In this case, we use MongoDB, and MongoDB is a versatile platform that excels at managing vector embeddings and relations, making it an ideal choice for applications that require advanced data retrieval analysis. And one of MongoDB's standout features is a graph lookup aggregation pipeline, which enables it to transverse graph and retrieve interconnected nodes. This capability allows MongoDB to seamlessly integrate the advantage of both a vector database and graph database, making it a powerful unified solution for optimizing your RAG solution. And with that, thank you.